Hello students, here in this video we are going to see the types of rates. In the previous video we have seen what is the rate of a chemical reaction, what is kinetics and what all signs we use to represent the rates of the reaction with respect to reactants, with respect to products and in general for the reaction. Now we will be studying in this video the two types of the rates what we will be using throughout the chapter. So the two types of rates what we'll be studying, they are average rate and instantaneous rate. So let us study both the rates one by one. So let us go for the first one, that is average rate. Now what is this average rate? It is the change in the concentration of the reactants or products with respect to time or divided by the time taken for the change. So how I can write this is average rate is equal to change in concentration of the reactants or products divided by the time interval over which the change occurs. So this is the formula for average rate. Now how I can represent this, student? That is change in the concentration. Change we denote by delta. So this is delta C upon delta T. So this delta C means change in the concentration of the reactant or the product. To understand this better, let us take an example. So example what I will take here is A goes to B. You know students, A is the reactant here and its concentration will decrease with respect to time, while B is the product here and its concentration will increase with respect to time. To denote the decrease, we use a minus sign or the word consumption or disappearance, while for the products we use plus sign or formation or appearance. So taking these revision factors, let us go for the rate of A. How to write this? So how I can write this, student? Rate of consumption or disappearance of A with respect to time. So how I will write this is equal to, now when it is average rate, we use a delta. As it is consumption or disappearance, I'll be using a minus sign. So it will be minus delta concentration of A upon delta T. This is how I will write. Let us write for the product also. So rate of formation or appearance of B with respect to time is, for formation or appearance we use a positive sign, so plus it will be delta B upon delta T. So this is how we write. Now next I will write for the reaction. So average rate of the reaction is, you have to write this first, then this. Follow a sequence. Go from reactant towards the product or come from products towards the reactant. Choice is yours. So it will be minus delta A by delta T is equal to plus. Signs, they are very important because they represent whether there is a decrease or an increase. So this is how you will write for the reaction. Now if I want to take one example, so let us write one of the example. Easy example you can have is H2 plus I2 gives 2HI. Let us write this now. So average rate of the reaction, how I will write this? This is the reactant, so its concentration will decrease. So minus delta H2 by delta T is equal to, this is also reactant, so minus delta I2 upon delta T is equal to. Now students, why we are writing this and how we are writing this, please refer to the previous video. So this is getting formed, so it will be plus half delta HI by delta T. So this is how I will write for the reaction. So I have written the average rate. Simple student, when you write the average rate, which symbol you will be using is this triangle. This triangle means the average rate. So it is the change in the concentration of the reactant or the product with respect to time that it takes for the change. Now let us see the graph here, and through graph we can explain why this is negative for reactants and why it is positive for the product. So let us plot the graph. Now the first graph what I will show here is for the concentration of the reactants. So let us take concentration of the reactant here. Here the reactant, you can take any one. So let us take the reactant here and with respect to time. So how I will draw the graph here? The graph will be the concentration of the reactant, you know it decreases with respect to time. So I will draw the graph in this way, student. This is what is happening. Now I will mark some time here. If I see the time here, this is 0. But as the concentration here, this will go on increasing in this way. Now let us mark when initial time, the concentration is maximum here. But as the time passes, so at this point, I will mark this in this way here. After some time, I'll mark this as this. Students, I will call this as time 1 and time 2. So this will be my C1 and this is my C2. So when I see the change in the concentration, change in concentration is equal to C2 minus C1 upon T2 minus T1. If I see the value of T2, T2 is greater than T1. So the change here will be positive. But if I see C1 and C2, C1 is greater than C2. Can you see this, student? Here C1 is more than C2. And therefore, delta C is negative. And so C2 minus C1, that is delta C, will be negative upon delta T. So change in the concentration of the reactant is negative because the concentration falls. Let us try the same for the product and see how it becomes positive. So for products, let us plot the graph. So for products, this is the concentration of the products and this is time. So how the graph will be? The graph will be something like this. Right, students? So let us mark the first time, that is said this is T1, this is T2. At this point, the concentration, this is your first concentration. I will call this as C1. And at time T2, let us mark this T2. The concentration here is C2. So what is change in concentration? C2 minus C1 upon T2 minus T1. Now if you see this, here C2 is greater than C1 and T2 is greater than T1. As C2 is greater than C1, their delta C must be positive, and therefore for products we use a positive sign. So here it will be plus delta C by delta T. So change in concentration of the products Why we write that as positive, that I have explained here. So you can calculate the slope also here through this same concentration. Now, this is all about the average rate. Let us go on to the second type of the rate, and that is instantaneous rate. Now, what is that instantaneous rate? Let us see that. Second type of the rate is instantaneous rate. Now, what is this instantaneous rate? It is the rate of a chemical reaction at a given specific instant. Means the rate at that given point, at that particular given point, and therefore it is infinitesimally slow. And so the change in the concentration is also infinitesimally slow. So as this rate is infinitesimally slow, the change in the concentration is also very slow or less. So students, we use the sign that is small d, that is infinitesimal small. Now let us take an example. A goes to B. Concept, everything is same, only in place of delta, what we have used for average, here we'll be using small d rate. So here let us write rate with respect to the reactant. What words I can use here is the rate of consumption or disappearance of A with respect to time is same. I'll use a minus sign. Now I'll be using D concentration A by dt. This is an easy way to write, and we prefer to use instantaneous rate for most of the reactions. Next will be rate of formation or appearance of B with respect to time is plus dB dt. So the instantaneous rate of the reaction, how you will write this, student? Minus dA dt is equal to dB dt. So this is how you write the instantaneous rate. Now what will be the graph for this? So let us see the graph. As I said, it is infinitesimally slow. The graph what I can show here. So this is your concentration of the reactant with respect to time. Graph will be same, but the observations, they will be made at instant time or a very small time interval, and therefore it is very difficult to plot the graph here, and so we simply draw a tangent in this way to get the slope. So this is a tangent what you have to show here, and then you will get here delta y by delta x, or you can have here C2 minus C1 upon delta T. For the reactant, it will be minus delta C by dc by dt. You have to use d for infinitesimal slow. Similarly, if I plot the graph for the products concentration with respect to time, then the graph will be something like this. Now, if I plot this, this will have a positive slope, and therefore it will be plus dc by dt. That is what you have to take into consideration, because for instantaneous rate, the reaction, it is infinitesimal small. So here we will have a negative slope of the tangent. Here we will have a negative slope, and here we will have a positive slope of the tangent at T1. Let us try one example. Now we can have the example of ammonia formation. So let us write ammonia. How it will be formed, student? Ammonia formation. Let us write the reaction for the ammonia formation. So it will be N2 plus H2 gives NH3. Balance the equation, you will get in this way. How you will write the instantaneous rate? So for that, let us go for this. So instantaneous rate of the reaction with respect to time is equal to, this is the reactant, its concentration will decrease, so it will be minus dN2 by dt is equal to, this is also reactant, its concentration will decrease, so minus 1 upon 3 dH2 by dt is equal to, this is products, its concentration will increase, so it will be plus half d NH3 by dt. So this is how you will write the instantaneous rate. Problems based on the instantaneous and average rate calculations that we will see in the coming videos. I hope you understood the concept of the two types of the rates. So you can practice few more examples, and so please do like my video and don't forget to subscribe my channel. Thank you, students.